Chapter 3.3 Notes, Properties of Functions, and the Difference Quotient, page 2. We want to look at this a little more formally. So we talked about the average rate of change being the slope between 2 points. So I'm going to throw that in there. Change in output over change in input, rise over run. We got delta y over delta x. How we saw it on the first page, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now we're going to formalize just a little bit and call it f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. The f of x sub 2 is just the fancy way to say y sub 2. Okay. So example 3, we are looking for the average rate of change on these intervals. So we can call this our x sub 1, this our x sub 2. Notice that we've got those square brackets. Those points are included. If this were an open interval, we couldn't really use those endpoints because they're not part of the interval. So we've got f of 5 minus f of negative 2 over 5 minus negative 2. And just so I don't mess anything up, I'm going to go ahead and put these in down here. 5 squared minus 3. 25 minus 3 is 22. F of negative 2. I got negative 2. These parentheses here are important. That's going to make that a positive 4 when we square it. Minus 3 equals 1. So I got, let's see, 22 minus 1 from below over 5 plus 2 over 7. 21 plus 7, which equals 3. B, our second interval, goes from 3 to some value b, and this is a little more consistent with how you're going to see it in calculus. So we want f of b minus f of 3 over b minus 3. Okay. And again, I will cram these in down here. F of b is b squared minus 3. F of 3, 9 minus 3, or 6. And so I've got f of b, b squared minus 3, minus f of 3, which is 6, all over b minus 3. Gives me b squared minus 9 over b minus 3, and watching for simplification, ways that we can simplify. I can factor this into b minus 3 times b plus 3. That numerator is a difference of 2 squares. I'm going to cancel my b minus 3's, and I end up with, I'm going to write it up here because I'm running out of room, b plus 3. And get this out of the way. Change colors. And so now we are looking at the closed interval from 2 to 2 plus h. So I've got f of 2 plus h minus f of 2 over 2 plus h minus 2. And remember, I kind of alluded to that last chapter, or last section, about why we had just that h in the denominator. Take a look at what's going to happen here. I've got 2 plus h minus 2. I'm going to end up with just h in the denominator, so that should be a little familiar. So again, f of 2 plus h, I'm going to see if I can cram it in here. 2 plus h squared minus 3. And I'm running out of room, so I'm going to shortchange here. Actually, let's go ahead and cram it in up top. 2 plus h times 2 plus h, and I get 4 plus 2h plus 2h plus h squared. 4 plus 4h plus h squared. And f of 2, I got 2 squared minus 3, 4 minus 3, which is 1. So here I've got 4 plus 4h plus h squared minus f of 2. Ooh, wait. Minus 3. Sorry about that. F of 2 plus h. I forgot the minus 3 part up here. So I've got, let me condense that just because I'm running out of room. 4 minus 3, I'm going to rewrite as 1. Minus my f of 2, which is 1. Notice here, because I did not plan well, I get 4h plus h squared in the numerator all over h. I've got h times 4 plus h all over h. Again, like we mentioned last section, these h's need to cancel, and we end up with 4 plus h. Well, let me see if I can highlight answers here to accommodate for my writing way too big and not planning well. Example 4 gives us a graph and a table for 2 runners running a 400-meter hurdle race. And then we've got questions that we are answering for both of those. A asks which runner has a faster average speed for the first 9 seconds. And so I'm going to take a look at the graph. And here is my 9 seconds. Notice that they start at the same spot. At 9 seconds, they're at the same spot, which we can also take a look at the table to figure out. So it's the same for the first 9 seconds. And we can confirm that mathematically. So runner A, from 0 to 9, they went 0 to 120, so we've got 120 minus 0 over 9 minus 0. I'm just going to reduce it and leave it as a fraction. 40 over 3, what are we looking at? Meters per second. And for runner B, 120 minus 0 over 9 minus 0. Again, 40 over 3 meters per second. I don't have to simplify anymore to be able to compare those numbers. Which runner has the faster average speed from 9 to 20 seconds? So let's take a look at what we've got here. So here is runner A. Runner A goes 168 minus 120 over 20 minus 9. I've got 48 over 11. Runner B goes 213. Now it's pretty obvious right now. Runner B has gone farther in those next 11 seconds. What is that, 93? Okay. And so I've got 93 over 11, which if I round that is, what, 8.45 meters per second, versus runner A at 4.36 meters per second. Runner B has a faster average speed, because 8.45 meters per second is faster than 4.36 meters per second. Always make sure you provide numbers to back up your statement. Not really okay to just say runner B is faster. You need to use the numbers to justify your argument. So from 20 to 31 seconds, I've got runner A, which goes 287 minus 168 over 31 minus 11. I get what, 119? Oops, 31 minus 20. I was a step ahead of myself, over 11. Runner B goes 287 minus 213 over 31 minus 20. And I get 74 over 11. Easy for me to compare in the fractions. I know that 119/11 is bigger than 74/11, so runner A was faster. If you want to use decimals to compare, this is what, roughly 10.81 meters per second. And here we got 6.73 meters per second. So runner A is faster. Average speed is faster for these 11 seconds because 10.81, is greater than 6.73. Which runner has a faster average speed from 9 to 31 seconds? So let's take a look at what we've got here. So A has run 287 meters at 31 seconds, 120 meters at 9 seconds. We get 167 over 22. And fairly obvious here, runner B is in the same place as runner A. I get 167 over 22 again. So they're the same. Between 9 and 31 seconds. Which runner wins the race? So we don't have the table going to that 400 meters. We're going to have to take a look at the graph. Notice that A hits that 400 meters, that Y equals 400, faster than B does. So A hits it at closer to 38 seconds. B is looking closer to 50 seconds. So A gets to 400 meters sooner. Based on the graph.